Hi, my name is Franz Vargas. I'm an electronics engineer student from San Jose, Costa Rica. This week's assignment will be about dynamic processors and their fundamentals, their basic concepts, how they work, and the different parameters these different processors or effects have. So let's get started. First off, to understand what dynamic processors are and how they work, we must first understand one little concept. Is the concept of dynamic range. Dynamic range basically means the difference between the highest noise or part in a sound piece or an audio file and the lowest one, the lowest level one. So the higher the dynamic range, the higher that difference is going to be. For instance, wave here and the little part here. The smaller the dynamic range, the smaller that difference is going to be. Let's look at a little graph so we can understand better this part. In this poorly drawn signal graphs, we can see the dynamic range in a more graphical way. The first way we have, this one has a high dynamic range. Why? Because there's a big difference between the highest noise, the highest part of the sound, and the quietest, the loudest and the quietest. You can see it's a big difference. So this has a high dynamic range. You're going to hear really loud noises and then you're going to hear really quiet noises. On the other hand, this small one, we have a low dynamic range. That means we have a smaller difference between the loudest part and the quietest part. So for instance, this will be the loudest part and this will be the quietest one. So the difference is much smaller than the one in the right. Now that we know this, we can now understand how dynamic processors work. First off, they basically manipulate the dynamic range. For instance, they can make it bigger, making the louder noises louder and the quiet noises, the quiet sounds quieter, or they can compress it. They can make the loud noise quieter and the quiet noise louder, so making this difference that we talked about smaller. There are 4 types of dynamic processors: compressors, expanders, limiters, and gates. Also, there are 4 parameters to each and one of these effects or processors. The first one is the threshold. Threshold is usually measured in decibels, so it tells when will the effect occur, at what level would the processor start to act. The second parameter is ratio. Ratio tells basically how much will the effect make or affect the sound. For instance, in a compressor, usually ratios are given in this way: 2:1. The first number represents the input, and the second one represents the output. So in this case, 2:1 compression means that for every 2 dBs of sound that come in, only 1 dB is coming out. The third one and fourth one are attack and release. These both are given in milliseconds, in time measure, usually milliseconds, and they mean how fast must the fader go. This affects dynamic processors usually work as a fader, as a really fast moving fader. So the threshold tells when will the fader move, the ratio will tell how much the fader will move, and the attack and release time will make how fast will the movement start and finish. The attack happens at the beginning of the sound per se. If you set a fast attack time, then the fader will move really fast, so you won't notice that transition between the silent part and the sound. If you set it if you set the attack time to a higher number, then the fader will move slower. The release time works on the other way, on the other part of the sound, at the end of the sound. So when it tells how fast must the fader go to its original position. So these are the 4 parameters you need to kind of work. When you want the effect to start, how much do you want to affect the input sound, how fast must it start the effect, and how fast must it go back to its original position.